learn data structures.
10 most important data structures which every programmer should learn.
Why data structure is very important for each and every programmer.
That's the power of algorithms.
The data structures and algorithms is a very important thing.
Hello, welcome in another important video. I hope you all are doing great. And in our last video we discussed about arrays and we also solved array rotation problem. Now in this video onwards we will discuss linked list and its types. So linked list is nothing but advanced type of array itself, but it just works slightly different. We'll see what are the differences between arrays and linked list, and we will also discuss why do we need linked list, what are the properties of linked list, and a whole lot of other things. Alright, so let's get started. So the first property of linked list is it follows linear data structure. Now if you remember, while discussing arrays, we discussed this. Arrays are also linear data structure. Now you might be wondering what is the difference, but there is a difference. I'll tell you in a minute. But before that, just observe this diagram. This diagram is representing perfect real life example of linked list, and this is an example of array also. Now in the diagram you are seeing there is a bunch of people who are standing in a row and they are trying to get into that bus. Now if you observe this closely, you will observe that every single person in the row is dependent on the person who is next to him or sometimes person behind him. If person A get into the bus, then person B will get chance to get into that bus. So in other words, we can say person B is dependent on person A. So similarly in a linked list and in arrays also, every single element inside of that array is dependent on an element nearby them. Now the legit question someone can ask, if this is an example of array as well as linked list, then what is the difference between both of them? Alright, so difference is in the next slide. So the difference between arrays and a linked list is, in arrays every single element is stored in a continuous memory location. But while at the other hand, in a linked list, although every single element is connected to the next element, but they are not in a continuous memory location. What does this mean? Okay, to understand this, let's observe this diagram. You see there is an array which is holding 4 elements, 55, 33, 22 and 11. So this is items inside an array, and the address top of each element is representing memory location. And to be specific, this is representing memory address. Now these are just an assumptions. In real case scenario it could be different, but the only thing you need to observe here is, if you see these addresses of an array of each element, you will see it is starting from 00x1, then the next element's address is 00x2, then the next is 00x3, 00x4. So now this is representing continuous memory, because after 1 that you will see 2, 3, 4. So this is representing continuous memory. Now let's observe same thing in a linked list. Although in a linked list we have same items 55, 33, 22, 11, but now in this case if you observe the memory address of each item, you will find differences. So now the first element address is 00x1, while second item in a linked list is 00x88. So now this diagram is representing how linked list and arrays work. Alright, although linked list and array are doing the same thing, they are storing some information inside of it, but the way they work is different. You see, arrays required continuous memory, but the linked list doesn't require continuous memory. So in this case, linked list is efficient than the arrays. So now another legit question someone can ask, why do we need linked list? And the answer to this question is, programmers found out some limitations in an array, and to solve those limitations they have created linked list. And the limitations what they found is, the size of an array is fixed. Now imagine that you are declaring some arrays. Either by the time of declaration you should know how much space will you require, because then only our memory allocation will allocate continuous memory location to that particular array. But that is not the case in a linked list. Since each element can be stored in different memory location, it just stores memory address of a next element in the current element. In this case, linked list is flexible in terms of memory allocation as compared to the array. Alright, So that's the reason why the linked list exists. Another important reason behind existence of a linked list is it's easy to add element in a linked list as well as delete element in a linked list. Now let's observe our previous diagram. Let's say if you try to delete 22 in an array. So in this case, you will delete 22, whatever the element further 22, you will have to shift all of them by one step left. So now this is expensive operation, because if you want to delete any particular element, you will have to perform shift operation on the elements next to it. So in an array, it's expensive process to delete any particular element. All right. But in a case of a linked list, since every single element just storing memory address, so in that case you just have to update memory address of the deleted item and you are good to go. So in a linked list, deletion operation is pretty easy as compared to the arrays. Same with addition of an element. So in an array, if you want to add any element in the middle of an array, so in that case you will have to shift every single element right next to it by one position. So that operation is also expensive. But in a linked list, if you want to add any element in between the linked list, so in that case you just have to update memory address of previous element and the memory address of next element, and you are good to go. So since there is some benefits of using linked list over the array, that is the reason why linked list exists. Okay, I hope you have understood why linked list exists and how it works differently than the array. All right, now let's move on to the terminology. All right, so let's start with the node. So node is nothing but every single element, or you can say every single item inside of the linked list. So you can compare this node with the item or element inside of an array. So pointer is nothing but pointing to the next element. So every single element in a linked list store a memory address which points to the next element. So you see this diagram, the first node has two columns, one which stores the actual data and another column that is representing the address box. So it will store address of the node B. Similarly, node B will store address of node C. Node C will store address of node D. So it will keep on going. So this pointer is nothing but pointing to the memory address of any particular element in a linked list. Alright. Next thing is data field. Now ultimately we want to store some data inside of the linked list. So you see the first column that is storing value A, that is nothing but data field. Right. So if we summarize this quickly, we can say in a linked list there is a nodes, and every single node should have at least two informations. First is the data that they want to store and the address of next node in a linked list. And that's pretty much all about the linked list. I hope you have understood the basics of linked list. In our upcoming videos, we will see different types of linked list and we'll also solve some problems. Alright. So I think that's it for this video. Thank you very much for watching. See you in the next video. Bye.